This is Guruji Online. Today we have brought some JEE Mains questions for you. So one of the question is before you on the blackboard. This question has come in 2015. It says the period of oscillation of a simple pendulum is T is equal to 2 pi root L by G. The measured value of L is 0.2 centimeter, known to 1 mm accuracy, and time for 100 oscillations is found to be 90 seconds using a wristwatch of 1 second resolution. So this is the two measurements they have taken with some accuracy. Now what they have asked is the accuracy in the determination of G is, these are the options. So we have to find out what is the answer. So we are given T is equal to 2 pi root L by G. This we can write as T square 4 pi square L upon G. Got it? Since we have been asked the answer accuracy in G, so G will be from this, G is nothing but 4 pi square L upon T square. Got it? Now this in terms of percentage accuracy equation, we can write it as delta G upon G into 100, because the answer we have been asked in percentage. This is in numerator, to delta L upon L into 100, then plus this is T square, so 2 delta T upon T into 100. Got it? Here delta L upon L. What is delta L? It is 1 mm, that is 0.1 centimeter upon L is 20 centimeter. It is basically 20 centimeter into 100 plus 2 into delta T is 1 second upon, it is 90 seconds into 100. So we can find out, this goes, this is 1 by 2 plus this is your this, if you will simplify, this will come as 22 upon 10. This will be nothing but 0.5 plus 2.2 that is 2.7, or it's coming as 3. So the answer is this. So this was a very simple problem, and now we will go to the next problem. So friends, this is the second question. It has come in JEE Mains 2015. As per this question, given in the figure are two blocks A and B of weight 20 Newton and 100 Newton respectively. These are being pressed against a wall by a force F as shown. If the coefficient of friction between the blocks like this, like here, and between the block B and wall like here, it is 0.1 and 0.15. The frictional force applied by the wall on the B is, these are 4 options given, we have to find out. So how to proceed? Let us first make the free body diagram. Free body diagram. This is block A. Force F is acting like this. It has got 20 Newton weight. Force F is like this. Same force will act here also. Now, the friction coefficient, that is mu, here is 0.1. So, this will have frictional force between these two block like this. If it is M, this is F, then this is your mu F. This is the frictional force acting, and this is nothing but 0.1 into F. Now, block B, free body diagram of block B, it is, this is F, this is F in this direction, so it will be in this direction. Now force is, frictional force is in upward direction, so here it will be in downward direction. It is the same force, mu F, 0.1 into F. Weight is given as 100 Newton. Between block B and wall, there will be frictional force, that is mu wall into your F. Mu, this will be nothing but 0.15 into so from this 20 Newton is downward direction, this mu F is in upward direction. This means mu F, that is 0.01 into F, is nothing but 20. F is nothing but 20 upon 0.1 or it is 200 Newton. Got it? Now, here for block B, here BW will be nothing but 100, it is in the downward direction, and then plus mu into F, that is here 0.1 into that is 20. It is 0.1 into F, or this will be 100 plus 20, and this is nothing but 120 Newton. This is basically the force, the frictional force applied by the wall on block B. This is what it is asking. When this frictional force, this wall will apply, then only the things will be in the equilibrium, otherwise block B will fall down. So the answer is, well friends, this is the third question. This has also come in JEE Mains. In 2015. What this question says, let us see. A train is moving on a straight track with speed 20 meter per second. So this is the train. It is moving like this. This is moving with V is equal to 20 meter per second. It is blowing whistle at the frequency of 1000 Hertz. So frequency F1, it's basically it is original frequency, that is 1000 Hertz. Now it is also given here the speed of sound as 320 meter per second. Now, suppose a person is standing here, the train comes here and it goes past him. So what will happen? Here, basically, the source, it is moving, and this is observer, it is stationary. So when it will approach to the observer, then this frequency will be changed and observer will hear a different frequency because it is moving, source is moving. So what will be that frequency? That is F1 Here that is uh, uh, 3, that is V minus Vs upon V into F0. It is nothing but 1000 into 320 minus 20 upon 320, and this will be, sorry, this is this it is it since it is source is moving, the formula will be like this. V minus Vs means 320 upon 320 minus 20, and this will be, if you calculate, this will come as 1067 hertz. It will be more than this because this is moving towards the observer. Now, once it passes from there, then the frequency heard by this observer will be less because it is going away from the observer. So, what will be the frequency when it passes away, goes away from the observer? This will be nothing but V upon V plus Vs. And this will be nothing but 1000 into 320 upon 320 plus, this is what? This, if you are going to calculate, it will come as 941 hertz. So what is the percentage change? (1006) divided by original frequency into 100. This is nothing but, if you solve this, this will come as 12.55%, or you can write it as 12%. So what is the answer? This. So I hope you understood these problems. JEE Mains problems are a little less difficult than what JEE Advanced are. So keep on looking our channel. We are going to bring for you the relevant problems which will be very useful in the exams. Thank you very much.